Hello, my name is Juliana Victoria Rivera, and I will be presenting on the physiology of the action potential. First, I will cover what is an action potential. So an action potential is the rapid and uniform electrical signal conducted down a cell membrane. Action potentials are uniform strength that travel from neurons that trigger the end of the axon. Action potentials are sometimes called all or none phenomena because they either occur as a maximal depolarization or do not occur at all. The strength of the greater potential that initiates an action potential has no influence on the amplitude of the action potential. Next, I will be covering the steps of the action potential. The first step is that the resting membrane potential happens. The second step is it depolarizes the stimulus. The third step is that the membrane depolarizes two threshold voltage-gated sodium and potassium channels, which then begin to open. The fourth step is that rapid sodium enters the depolarized cell. The fifth is that sodium channels close and slower potassium channels open. The sixth step is that potassium moves from cell to extracellular fluid. The seventh step is that potassium channels remain open and additional potassium leaves the cell, therefore hyperpolarizing it. The eighth step is that voltage-gated potassium channels close. Then, the less potassium leaks out of the cell. The ninth and final step is that the cell returns to the resting ion permeability and resting membrane potential. Next, I will be covering how the action potential propagates down an axon, but not up. So this happens because it is achieved that the sodium channels have a refractory period following the activation. So once they opened up, they can't close again because they've already opened. The closure makes sure that the action potential goes through the specific direction. It travels in one direction because the potassium channels in the neuron are refractory and cannot be activated for a short time after they open and close. As I've mentioned before, action potentials travel in only one direction down an axon because the sodium channels in the neuron are refractory. Next, I will be covering neurotransmitters. So, how are the neurotransmitters released? The neurotransmitter is released by a neuron that combines with a receptor on the target cell and initiates a response. So when an action potential reaches the presynaptic terminal, it causes the neurotransmitter to be released from the neuron into the synaptic cleft. This response is usually short because the neurotransmitter is rapidly removed by the mechanisms. And then it reaches to the postsynaptic cell. Well, I have covered the action potential, what it is, the steps of action potential, how the action potential propagates down an axon but not up, and how the neurotransmitter is released. Thank you so much for watching my presentation. Have a good day.